that was one of the first finger-style songs that I learned many years ago, a little bit of that. All right, so let's see. We will be working on law of cosines. Now, this section I'm going to break up primarily into three parts. We're going to look at what the law of cosines is. We'll look at some applications, and then we're also going to look at what's called Huron's formula, finding an area of a triangle. All right, so to begin with, law of cosines is not to be confused with law of sines. It's different formulas. So what we do on law of cosines is, again, if you've got three parts of an oblique triangle given, in certain cases you have to use law of cosines. So if you have the side case, where you have three sides, or the side angle side case, then you have to at least start the problem by using law of cosines. All right, now you can do law of sines after you're done with that step then. So the law of cosines, there are three forms of this. These are the three formulas right here that apply to any triangle. It can also be a right triangle. And you want to know these formulas. I'm going to show you how to memorize these. They look like they're kind of complicated, but they're actually not that hard to memorize, and there's benefits to memorizing these things. One thing that you're going to need to be able to do in certain cases is to take these formulas and solve them for the cosine. You don't have to memorize this version of this because it's pretty easy to derive that and solve that. So what I'm going to do first of all is just show you down below how to memorize the law of cosines formula. All right, so let's go down here and let's go ahead and just label this. Let's label that angle as alpha, that is beta, and that is gamma. And then this would be A, and would be B and C. That's the naming convention that we're familiar with. So what I'm going to do is I'm going to show you how you do this and how you build these things. So first of all, what you do is you pick a side and you square it. Okay, and then that will always be the sum of the squares of the other two sides. Like that. That's almost kind of looks like the Pythagorean theorem almost. Then what you do is you do minus twice the product of those two sides. And then you do the cosine of the angle that's opposite the angle A. So in that case, that's alpha. Okay, so you just pick a side and square it. It's going to be the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the angle that's between those two sides, B and C. Okay, so it goes like this. If you look at this, that's the A squared. You got the other two sides, twice the product, cosine of the angle that's in between. So those are the things that are related, and that gives a side angle side case right there. So the second version of this would go like this. Again, you just pick a side. Okay, you got B squared. That's the sum of the squares of the other two sides, which would be A squared plus C squared, minus twice the product of those. And then it would be the cosine of beta, since that's opposite the B. Okay, so it's not that hard to remember this then. And then the last one, C squared, the sum of the other two sides would be A squared plus B squared, minus 2AB, and then the cosine of the angle opposite C, which would be gamma. All right, so that's how you put together the law of cosines. All right, so if you're given a side angle side and all three sides, that's when you got to use law of cosines. All right, so let's see. Going on to this next page, we're going to begin to look at the different cases. So I'm going to do one of each case here. And this one, I'm going to show you how the side angle side case goes. We're going to find the remaining parts of this triangle. So what that means that we're going to need to do in this problem is we're going to need to find gamma, we're going to need to find alpha, and we're going to need to find side B. All right, so we've been given these things. So the first thing we want to do is we've been given a side angle side case. So that means we have to start by finding this side opposite the beta. So we're going to start by doing the law of cosines. So I'm going to write down the correct formula. And the benefit of memorizing this is it does speed you up a little bit. So I just go B squared equals the sum of the squares of the other two sides minus twice the product of the other two sides, and then it's the cosine of the angle in between those two given sides. All right. So notice in this problem, you know AC, and you know this angle 30 degrees like that. So I probably should write that like this to begin with. I'm going to write this as cosine of beta. So my point I'm trying to make is you know everything except this. All right. And that's why you can use the law of cosines. Now we're pretty well just going to go to the calculator. So let's see. Side A is 10. So we have 10 to the second. C is 12. And we have 2 times A times C. And then we have the cosine of 30 degrees. Okay, now you can pretty well just do this in one step on your calculator, which is what I'm going to do on here. And the calculator is going to do this correctly. You can do whatever you can in your head. So I'm going to do 10 squared plus 12 squared. Okay, then I'm going to do minus 2 times 10 times 12. And then times the cosine of 30. You want to make sure, of course, you're in degree mode when you're doing this. So we'll get that, and then we'll record that. All right, so that's going to give b squared is equal to, and I'm just going to round these off to 1 decimal as I go. All right. So what I'm going to do is now I'm going to do the square root of both sides. And probably what you ought to do is do your rounding at the very end here. So you don't really, when you're doing these problems, have to write all these decimals out because you're going to do it all on the calculator anyway. But I'm going to do that as I'm teaching this. So we do square root of both sides. So now I'm just going to go square root. Remember, that's in the memory key, which is stored in ANS. So I go second negative. That's the simplest way to do that now is when you should round. So we get B is approximately 6. Okay, just round that to 6. So we do have that taken care of now. All right, so that's step 1. You have to use the law of cosines, and I'm going to put these things in as I get these then. All right, so that's the law of cosines. Now step 2, it's probably best that you just go through and use law of sines, because law of sines to me is a little bit easier to work with than law of cosines. So the other thing we need to do is we need to find an angle. So I'm just going to pick which angle I want to do. I'm going to go ahead and start by looking at angle alpha. Okay, I know the side opposite, so that tells me I can use law of sines, and then I'm going to match up this with this. Okay, so I'm going to choose to do it that way. We could also find gamma in the same way if we wanted to. All right, so I'm just going to use law of sines. So I'm going to say sine of alpha over the opposite side is equal to, and then I'm going to match up the 6 that we just found over the sine of beta, which is 30 degrees. Okay, so that gives us the law of sines ratio, and then I can put this together. So really all I need to do on this is, now that I've got, whoops, I did that backwards. I wasn't paying attention to that. I thought that looked weird. So I made the decision to put the angles on top, so it would go sine 30 degrees over 6. Okay, like that. Sorry about that. Okay, now I'm multiplying both sides by 10, and I'm not going to be showing all the steps like I was in the last section all the time. You can do this part in your head. So you get sine of alpha is equal to 10 sine 30 degrees all over 6, and then I'll go to the calculator on that. So I've got 10 sine 30, and then divide that by 6. Just write down what all the decimals are. So that's giving sine alpha equals, and that looks like that's just repeating 3's. And then alpha is going to be the inverse sine. And I'll just go directly to the calculator to get that then. So then we'll have approximately what alpha is. So I'm going to go second sine, and then use the ANS key so I don't have to type all those digits out. So I'm going to round that off to 56.4 degrees. Okay. All right, so I got that now. So I've got these two pieces. I use law of cosines, then law of sines. Step 3, all I got to do is find that last angle. So we got alpha is 56.4 degrees. All right, so how do I find gamma? Well, gamma, all I got to do is subtract those two angles from 180. So I take 180 degrees minus 56.4 minus 30, and then that'll give me the answer to what gamma is then. Okay, I'm going to slide this over the side here. All right, and when I do this, I'll be done with the problem, and then we are going to check this. I want to remind you of how you can check your answer with law of sine. So I got 56.4 minus 30, and that's going to be 93.6 degrees. All right, so problem is done. Now let's go ahead and take a little time just to check and verify. I always recommend you do this if you're doing like a test or you're doing your homework and you're not confident if you're doing this right. I mean, hey, there's nothing to checking this stuff. So what I'm going to do is I do this. I've shown you how to do this before. What I do is I just pick an angle. I'm going to start with sine of 30. And then I'm going to divide that by its opposite side, which is 6. Then I'm going to pick another angle. So I'm going to do sine of 93.6, divide by its opposite side, which was 12. Okay, and we're getting about the same thing. And then do the sine of the other angle, 56.4, and divide by its opposite side, which was given as 10. So that all pretty well verifies that. We're just off a little bit because of the rounding, but that verifies that we're on track with getting the right answer to that problem then. Okay, so I always recommend that you do that. Doesn't take any time at all to do that. All right, so that's how you handle the side angle side case, is you have to start by finding the opposite side of that given angle using law of cosines. Then it's just as well to move on to law of sines in your second step. Okay, now what we're going to look at is the other case where you can use law of cosines, is when you're given all sides of a triangle. So I'm going to draw a triangle. You don't necessarily have to do this, on this problem. You just know that you're given all sides. I'm just going to label this as alpha, beta, gamma. I don't really care if I'm drawing it to scale or not. So I gave side A is 18 centimeters, side B is 16 centimeters, and side C is 21 centimeters, like that. So you can actually start with any version of law of cosines that you want. It doesn't matter. So you can go back to the formulas and you can pick any of these you want to. It doesn't matter. I'm going to start, I guess, with, let's see, the last problem I used, we were given beta. I'm going to start with alpha. So I'm just going to write down that formula. Again, try to memorize it. A squared is the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the angle that's opposite A, or alpha. Okay, that's how that goes. Now, what I like to do on this problem, you can go ahead and plug in now if you want to, because notice that in this formula, the only unknown is alpha. That's why we can use law of cosines. But what I like to do is just solve this equation for cosine of alpha. In the textbook, they've done that for you, and you could certainly write that down. I wouldn't rely on that. I would just, solve this as you go, because there's nothing to it. So I'm going to move the b squared and c squared, so I get a squared minus b squared minus c squared is equal to negative 2bc cosine of alpha. Then I can divide both sides of this equation by negative 2bc. And then I like to plug in when I get to that point then. So I've got a squared minus b squared minus c squared all over negative 2bc is equal to the cosine of alpha. Okay, now I'm going to plug in everything I have here then. Okay, so we just plug in. A is 18, so I've got 18 squared. B is 16, so I've got 16 squared. C is 21. And then down on the bottom, I need to do negative 2 times B, and then times C, and then that's equal cosine of alpha. Be real careful when you do this in the calculator. I generally recommend to students, you can do this in one step if you use your parenthesis keys, okay? I generally just recommend, to be safe, just work out the numerator. So I'm going to do 18 squared minus 16 squared, and minus 21 squared. And then I'm just going to record that on my paper, and that is negative 373. Then I'm going to do the bottom, which is negative 2 times 16 times 21. And that will give negative 672. That's equal to cosine of alpha. Students a lot of times mess up on these negatives. So what you end up doing now is alpha is just going to be the inverse cosine of this expression. The two negatives divide out to make a positive. So I'm just going to put that in my calculator like that then. Okay, so that's how I recommend you do that. So I'm going to go inverse cosine of 373 divided by 672. And then this will give an angle, and I'm going to just round this off to 1 decimal. So I've got 56.3 degrees is approximately what alpha is then. All right, I'm going to record these answers as I get these. So I've got alpha is about 56.3 degrees. All right, so that's step 1, and I'm going to write that in now. So alpha is 56.3 degrees. Now we have to find either beta or gamma. It doesn't matter where you start. I'm going to go with, I guess I'll go with gamma, just my decision. So step 2, I can now do law of sines. So I can match this up with the opposite side, and then I have to match up the alpha and a. So I've got one unknown in that law of sines ratio. So I just say sine of gamma over the opposite side 21 is equal to sine of 56.3 degrees over its opposite side like that. Okay, I need to multiply both sides by 21. You can start doing that in your head. So I've got sine gamma is equal to 21 sine of 56.3 all over 18. Then I can go to my calculator to find that then. Okay, so let's see. Let me clear this off and let's do that. So I'm going to do 21 sine 56.3 divided by 18, and that will give this. Okay, I'm just going to write this down just kind of as a record, and then what I can do is I can do the inverse sine of this on the calculator, so I don't have to write all these decimals out. Okay, so let's do that. Mostly I was going to mention on a test, mostly what I'm looking for is the setup. So you don't necessarily have to write these steps right here because you're going to do that on your calculator anyway. So I'm going to go inverse sine, use the A and S key, and then that'll give the next angle. So I'm going to round that off to 1 decimal, so that's about 76.1 degrees. So we got the second part of our problem done. And then one more step and then we're done, and then we can quickly check this if we want to. So let's see, beta, hold on, that's gamma, so I put that in the wrong place. So let's see, gamma is 76.1. All right, I'm going to fill that in, and then we don't need to do law of sines to find the next angle. We just subtract from 180. So the third step on this is we'll get beta. Beta is just going to be 180 degrees minus the 56.3 degrees minus 76.1 degrees, and then that will finish up the problem for us then. So I'll do that on the calculator. All right, and that'll give us, wrap up the other angle. So that angle is going to be 47.6 degrees. So now the problem is solved. Okay. Okay, now you can do a check on this if you want to. I think I'm going to go ahead and do that. I like to do that when I'm doing my videos so I don't make mistakes on this. So I'm going to go ahead and do this real quick. So again, this is just kind of what I do on this. Is I like to do it this way. I just pick an angle. So I'm going to start with sine of 76.1 and divide by the opposite side, 21. I'm just doing law of sines. I pick another angle, so I'm going to go with 56.3, so sine of 56.3 And I'm going to divide by its opposite side. Just kind of seeing that we're about the same, so we're good there. And then finally, the last angle was 47.6, so we do the sine of 47.6 and divide by its opposite side, which was 16. So right there, that verifies that we're on the right track. Okay, you're just off a little bit again due to rounding. All right, so that's good. I've given you an example of a side, 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 and a side angle side case, so I'm going to let you go to the next page and work on one of each of those. So I've given you two cases. It's always good to draw a triangle if I don't give you a triangle. And let's see, part B, so I'll let you work on those and come back and check your answers. So go ahead and pause the video, work them out, and I would check my answer too, like I've been showing you. And then if you know you got them right, then you're good. All right. Okay, so let's see how we did here. I'm just going to try to display this so you can check all of my answers. So on the first problem, you were given the side angle side case. This is what you should have come up with. Side B is 12.1 inches. Angle A is 47.9. Whoa, hold on. What, did I write something down wrong on here? Yeah, that's angle A. I guess this is C. Yeah, I just wrote this down wrong. So C, angle C, is 61.9. Okay, the second problem was side, side, side. What you should have came up with was angle beta is 39.9 degrees, angle gamma was 117 degrees, and angle alpha was 23.1 degrees. So I'm just assuming we're just going to round these to one decimal in general unless I state otherwise. All right, so you can look over everything I did on this. If you got these right, then you can go ahead and close the video, and then you can look at the second part of this video when I produce that. So I'm going to zoom on this a little bit and just go over a couple of things that you might need to check. I do want to stress that what matters, of course, is that you get the correct answer. You might not go about doing this exactly the same way I do. You may do things a little bit different, particularly on the law of sines. And the law of cosines step on this first problem has to be done this way. So I went ahead and drew the triangle. You want to make sure you did that okay. And I used this law of cosines formula, and then I just plugged in the numbers. So A was given, C was given, and then the angle B was given. So I crunched this out to get that 12.1. All right, so that's pretty straightforward. You have to start, if you're given side angle side case, you have to start with finding the side opposite that angle, and you have to use law of cosines. There isn't any other way to get that side done. Now from here it's up to you. You could also find angle C before you found angle A. It doesn't matter. I just decided to match up the sine of A with its opposite side and the sine of 71 with its opposite side. So I got 47.9. Once I have that angle, then you can always find that last angle by subtracting the two angles from 180. So that's what I did there. You could have done this slightly different by finding C before you find A. Okay, the next problem was the side, side, side case. And you really decide where you want to start. Now, you could have used either form of the law of cosines. You could even use the law of cosines 3 times to find all 3 angles. But I find it best to use law of cosines in the first step, then go to law of sines. Okay, so you only have to use trigonometry for the first 2 steps, and then the last step you can find that missing angle the easy way. So I decided to just use this. I solved this for cosine of alpha, so I plugged in to this formula after I solved that for cosine, and I ended up getting, you can kind of see the arithmetic I did. I ended up doing the calculation. You can look at all of my calculations I did on the calculator if you need to too, and that gave 23.1. All right, so I got that. So that's the law of cosine steps. You want to look over that if you need to. Then I decided to go ahead and find beta. I could have found gamma instead of beta in step 2. So I just did this. So I did sine beta over opposite side is sine 23.1 over opposite side. Then I went through the process of law of sines and got 39.9, and then I closed it off by finding gamma. Now I did check. You can look at my check and verification step on both of these problems if you want to. So I was relatively close. You always should be within 2 or 3 decimals. You're going to be off because of the rounding, obviously, but both of those problems checked out. You can look and see what I did on both of those if you want to. Okay, so that's how you handle law of cosines. As long as you can do the formula okay and use your calculator okay, because you're going to need to do your calculator, you should be fine with doing this then. So I'm going to go ahead and close this off. That'll be the end of this video. I'll produce a second part where we just look at word problems, then a third part where we look at area of triangle and Heron's formula. All right, good luck.